Hello, this video is for Algebra 1 textbook, Chapter 2, Lesson 9. The title of the lesson is Percents, and our objective is to solve problems involving percents. The vocabulary for this lesson is percent. So who uses this? Well, jewelers use percent to determine the purity of precious metals. And we see some jeweler rings over here, so we'll look at that in example 4. A percent is a ratio that compares the number to 100. Remember, a ratio is the comparison of two numbers using division. So basically, it's a fraction, right? We can write a ratio as a fraction. So a percent is a ratio that compares a number to a 100. For example, 25% is 25 over 100. The percent sign actually means parts of 100. So if we were to read 25% and think of percent as parts of 100, and we said 25 parts of 100, then we could see where we would come up with 25 over 100. Because remember, the numerator shows the part, whereas the denominator shows the whole. To find the fraction equivalent of a percent, write the percent as a ratio with a denominator of 100. And then, if possible, simplify. So 25% is equal to, well, 25 parts of 100, or 25 over 100. And then we could simplify 25 over 100 because 25 and 100 both will divide by 25. So 25 divided by 25 is 1, and 100 divided by 25 is 4. So 25 over 100 simplifies to 1/4. To find the decimal equivalent of a percent, divide by 100. So if we take 25%, again, we're going to write as 25 parts of 100, or 25 over 100. And then if we divide 25 by 100, because remember, every fraction is a division problem, 25 divided by 100 equals 0.25. Here are some common equivalents here in this table. We have a row for percents, a row for fractions, and a row for decimals, how all of them convert. Think of some of the more popular ones, like 1/2. This is a pretty popular one. 1/2 is equal to 50%, or is also, as a decimal, is 0.5. Another popular percent is 25%. As a fraction, that's 1/4, and it's written as 0.25. And so we've covered 25%, 50%, 75% is another popular one. As a fraction, it's 3/4. As a decimal, it's 0.75. What are some of the other popular ones? Maybe 10% is written as 0.1, or 1/10, 1 part of 100. Other ones that are popular, like the 20%. Notice that the 20, 40, 60, and 80%, those are broken into fifths, right? Because 100 will divide evenly by 5, and that equals 20. So there are 5 20ths inside of 100. So if you think, you count 20, 40, 60, 80, 100, right? So 20% is 1/5, or 0.2. 40% is 2/5, or 0.4. 60% is 3/5, or 0.6. And 80% is 4/5, or 0.8. Also, 100%, well, is not a fraction, it's just 1, right? And it's written as 1.0. So the greatest percent shown in the table is 100%, or 1, but percents can be greater than 100%. For example, 120% is 120 parts of 100, or 120 over 100. And then if we convert that to a decimal, 120 divided by 100 equals 1.2. You can always find the decimal if you have to. If you don't want to do long division, you could always use a calculator. Just type in 120, hit the divide sign, 100, hit equal, and it's going to pump out that 1.2. You can also find percents that are less than 1%. For example, 0.5%. 0.5 is less than 1, right? Well, this is 0.5 parts of 100. So if we had that as 0.5 parts of 100, it'd be 0.5 over 100. And then if we put that into a calculator and hit enter, divide 0.5 divided by 100, we would get 0.005. Also, basically, the decimal moves, whenever you change it from a fraction to a decimal, the decimal moves over 2 places to the left. You can use a proportion where we have the part is to the whole as the percent is to 100 to find unknown values. And we'll now go ahead and take a look at some examples that do that. So example 1, finding the part, we're going to use the proportion method. We're going to find 50% of 20. So part is to the whole as percent is to 100. So what is the part, what's the whole, and what's the percent? We always know the denominator over here in this proportion is going to be 100. So our part, that's what we don't know. 50% of 20. 20 is the whole, so we're going to put 20 in the position of whole. The percent that they give us is 50. 50 parts of 100, so we have 50 over 100. Now we've got our proportion set up. Let's go ahead and use cross products. X times 100 is 100x. 20 times 50 is 1,000. Divide both sides by 100. That will eliminate the 100 on the left and leave us with just x. And 1,000 divided by 100 is 10. Therefore, x equals 10. So 50% of 20 is 10. Now you could check that and think 50% is the same of 1/2. And 1/2 of 20 is 10. So you probably could have done that without the proportion method. And that's the one reason why knowing how to, some of the popular percentages of knowing that 50% is equal to 1/2. And if someone asks you what's 1/2 of 20, you'd be like, oh, half of 20 is 10. Now let's find 105% of 72. Now this is greater than 100%, right? 100% of 72 would be 72. So we should be expecting a value that is actually greater than 72. Method 2, we're going to use an equation. So one thing I want to point out here, the textbook really doesn't talk about, is that the word of implies that we should multiply. M-U-L-T. I just put M-U-L-T for multiply. So we want to find 105% of 72. So we're going to go ahead and put that down. X, what we're wanting to find, right? And X is equal to 105% of 72. Well, of means to multiply, so we're having multiplication here. We don't have an operation sign here, so we know this means to multiply. We just have this number separated by this number because it's contained inside of the parentheses, so we know that we should multiply here. Now 105%, we're going to change that to a decimal, and move that decimal over 2 places, and we would get 1.05. Now if we go ahead and multiply 1.05 times 72, we're going to get 75.6 is our answer. So 105% of 72 is 75.6. I'm going to do a couple examples here. Let's do this one using proportion and this one here using the equation method. So 20% of 60%. So remember, we're going to do part is to the whole as the percent is to, and this is always 100 down here, right? So 20% of 60. So we're missing the part, right? 60 is the whole. So we're going to say x over 60 is equal to, and then the percent is 20. So we'll put 20 over 100, or 20 parts of 100. Let's do cross products. 100 times x is 100x. And 60 times 20, well, 6 times 2 is 12. And we got a couple zeros on there. Now we're going to go ahead and divide both sides by 100. And whenever we do that, we end up with 12. So x equals 12. Over here on this one, 4% of 36. So find 4% of 36. So let's say what we're looking for, we'll just call it x. And we want 4%, so let's write that as a decimal. Move the decimal over 2 places, and we would have 0.04. Of means to multiply, so I'm just going to put parentheses here and throw that 36 in there. Oh, not what I want. There we go. Previous space. There we go. So, wrong button push. Let's go ahead, and I need to fix something here. I'm just going to use the eraser there. So let's see, I was putting 36 in this box, right? There we go. So now we go ahead and multiply 0.04 times 36. I guess I could do that by hand really quick. 6, 6, 12, 24, carry the 2, 12, 14. 144, and I need to move the decimal over 2 places right there, 1.44. So does this answer make sense? Because I had that whole decimal moving thing, right? So let's think about this. 4% is what we're looking for. Well, 10%, I know that 10% of 36 would be 3.6. And so I have 1.4 here. 4% is just a little less than half of 10. And 1.4 is about a little less than 1/2 of 3.6. So my decimal seems to be in the correct place. If I would have gotten 14, I would have known I was way off. If I would have got 0.144, I would have known I was way off as well. So just kind of make sure that your answers make sense on that. Let's go ahead and look at the next page. Here is example 2, finding the percent. So we found the missing part. Now we're going to be looking for the percent. So what percent of 60 is 15? And over here at the helpful hint, let's take a look at that. Before solving, decide what is a reasonable answer, kind of like I was talking about on the last one. For example, 2a, here we are in 2a, 50% of 60 is 30, so the answer will be less than 50% of 60. So I guess what they're saying is that what percent of 60 is 15? Well, 50% of 60 would be 30. Right, so we should be looking for an answer that is less than 50%, right? I think that's pretty much what they're wanting to tell us. So part is to whole as percent is to 100. What do we have? We have the part and we have the whole. 15 is the part, 60 is the whole. So 15 and 60 in their respective locations. The percent is what we don't know, so we're going to call that X. Now let's do cross products. And I always like to keep my extremes on the left. I would do 15 times 100 is 1500 and put that over on the left. And 60 times x is 60x and put it over on the right. But nonetheless, I suppose the textbook always likes to keep the variable on the left to keep you comfortable with that process. So I suppose we'll go ahead and do it their way. So we end up with 60x equals 1500. 15 times 100 is 1500. Divide both sides by 60. And the 60s cancel each other, leave me with x, and 1500 divided by 60 is 25. So x equals 25. It is 25, and then that, remember we're looking for a percent, so if we write that out, 15 is 25% of 60. All right, let's look at our next page. 440 is what percent of 400? So 440 actually is the part. Part's actually greater than the whole this time, so we should be looking for some number that is greater than 100 because the part's actually greater than the whole. So let's go ahead and use an equation here. 440 is, think of this, is as an equal sign. What percent, so this is our percent that we're missing, of means to multiply, and we have 400, right? So we would end up with 440 equals the percentage, and are they using, yep, we're using the equation method. So with that in mind, let's go ahead and try to apply that to what we see here. So 440, right, is x, the unknown percent, times 400, right there. We just kind of put it together, translate it from this statement here over to a mathematical sentence. Now we go ahead and multiply x times 400 is 400x, bring down our 440. Let's divide both sides by 400. That's going to leave us with just x on the left, and 440 divided by 400 is 1.1. Now we're going to move that decimal over 2 places, 2 places, put a 0 in there, and you can see that we would get 110%. Whenever you change a decimal to a percentage, the decimal moves to the right. Whenever you move a percent to a decimal, it moves to the left. Here's a little memory device for that. Which comes first, D or P in the alphabet? Well, D comes before P. So if we're going from a decimal to a percent, the decimal's moving to the right. And if we go from percent to decimal, then the decimal is going to move to the left. Kind of a little memory device for you there. So if you ever get confused which way is the decimal supposed to go, well, if you're going from decimal to percent, we're going to move the decimal to the right. And if you're going from percent to decimal, you're going to go ahead and move it to the left. So we found out that 440 is 110% of 400. So let's try this on these problems down here. What percent of 35 is 7? So let's go ahead and do the proportion method on this. So the part is to the whole as the percent is to 100. Let's go ahead and fill those in. So what percent? So it's the percent that we don't know, right? So we'll put in X for percent. Now we just need to determine the part and the whole. What percent of 35 is 7? So 7's the part. 35 is the whole. So 7 times 100 is 700. 35 times X is 35X. And I think I know this answer because it's 5 parts. I'm trying to do the cheating on the mental math here. We divide both sides by 35, and should be 20, I think, right? Let's check that out. Let me double check that. 700 divided by 35. 700 divided by 35 equals, indeed it is, 20. Because I know that 35 goes into 70 twice, and then you got the 0. That was my mental math on that. All right. On this next problem, we'll use the equation method. So 27% is what percent, the unknown, of multiply 9. So we have 27 equals X times 9, or 27 equals 9X. Divide both sides by 9, and 27 divided by 9 is 3. Therefore, in this case, X equals 3. But it wants to know percent. So we need to go ahead and move. 27 is what percent of 9? Oh, yeah, 20 of 9. Yeah, 9's actually the whole. So in this case, we have 3, right? And we need to move that decimal over 2 places because we're going from a decimal to a percent. So remember up here, decimal to a percent, move it to the right. So that's 300, throw a percent sign on the end. So actually, 3 is not our answer. Got to be careful there. Go ahead and change that over. 300% is the answer. And over here, 20, if I change that to a percent, we need to actually throw a percent sign on the end there. And it's 20%. Finding the whole. So we've had the missing part. We've had the missing percent. Now, what if it is the whole that is missing? So 40% of what number is 14? Here we're going to use a proportion. So part is to whole as percent is to 100. We're missing the whole, so that's going to be down here in the position of the denominator on the left. 14 is the part, and our percentage is 100. So 14 times 100 is, and again, I like to keep my extremes on the left, but they like to keep the variable on the left. So I would have gone 14 times 100 is 1400, and 40 times x is 40x, and then my variable would have ended up on the right. But they like to keep their variables on the left, so what the heck, we'll go ahead and do that. 40 times x is 40x. 14 times 100 is 1400. And then divide both sides by 40. I would get x on the left, and 1400 divided by 40 is 35. So 40% of 35 is 14%. In case you're wondering why I like to keep my extremes on the left, is that whenever you have something like comparing fractions using inequalities, it works out pretty cool that 3/4, and let me see, I'll pick out something here, 10 and say 7/10, which is greater, 3/4 or 7/10. Well, if you keep your extremes on the left, 3 times 10 is 30, and 4 times 7 is 28. We see that 30 is greater than 28, so 3/4 is greater than 7/10. The sign doesn't change. That's why I like to keep my extremes on the left and my means on the right. And now you're like, what are extremes? What are means? So if you haven't watched my videos before, if I have 3 is to 4, and I consider that, I try to compare that with, well, is this equal to, and let's come up with something that it is equal to. Let's multiply them both by 2. 6 is to 8. Well, in the middle is the 4 and the 6. So they're in the middle. They are the means, M-E-A-N-S. And what's toward the outside? The 3 and the 8, right? So, and these are the extremes. And if I were to write these as fractions, 3 over 4 equals 6 over 8. Where does the 3 and the 8? They're right here and here. That's why I call those the extremes whenever I cross multiply. And what's in the middle? Close to the middle, where are the 4 and the 6? The 4 is here and the 6 is here. So my extremes are in circles and my means are in squares or boxes or something like that. But that's why I always keep my extremes on the left. It's a good habit to get into because it works great whenever you're working with inequalities and you're comparing fractions. So, all right, on this one here, we're going to use the equation method. 40 is, so 40 is means equals 0.8%. So we want to go from a percent to a decimal. So our decimal is going to move to the left, right? So it's going to go over 2 more places, 1, 2. So we're going to have 2 zeros. So 0.008 of means to multiply what number? X. So we would end up with that there. Let's see if they get the same thing. 40, yep, equals 8% of X. And then we get 40 equals 0.008 times X, which is what we have up here. Divide both sides by 0.008, and you get just the X on the right, and 40 divided by 0.008 is 5,000. So we find out that 40 is 0.8% of 5,000. So let's do a couple of them here. We'll use the proportion concept. So part is to whole as percent is to 100. Well, we know the percent is 120, so we'll fill that in. What number is 120% of what number is 90? So 90 is the part. It's the whole that we are looking for. So let's do 90 times 100, 90, and throw 2 more zeros on there, right, for 9,000. And 120x. Now divide both sides by 120. I'd end up with x, and let me see, 98. I'm trying to mental math that one. It's not coming to me that easily. So let's do 9,000. We're going to divide it by 120, and I'll probably be like, oh, I should have known that. It's 75. 75. So x equals 75 up here. So does that make sense? Well, 90 is greater than 75, and we're looking for more than 100%, so we should expect the part to actually be greater than the whole. So the answer does make sense. 48 is 15%, going from percent to decimal, so let's write this decimal moves to the left, of multiply what number we'll call x? 48. So we have 48 equals 0.15x. Let's divide both sides by 0.15. 0.15 and 15 into 48. I don't think I'm going to mess with that one too much. Let's go ahead and do 48 divided by 0.15, and we come up with 320 equals 320. And those cancel, so we just have x here. So 320 is the number we're looking for. So 48 is 15% of 320. And that brings us to our example of the jeweler that we saw on the first page. So career application here in example 4. Jewelers use the carat system to determine the amount of pure gold in jewelry. Pure gold is 24 karat, meaning the item is 100% gold. So if you have a 24 karat piece of jewelry, 24 karat gold, that means that it is pure gold. A 14 karat gold ring contains 14 parts of gold and 10 parts of other metal. What percent of the ring is gold? Round your answer to the nearest percent. So we're using the proportion method. Part is to whole as percent is to 100. So 14 is the part, 14 carats. The most carats it can be is 24, so 24 is the whole. The percent is the missing part. Let's go ahead and do cross products. 14 times 100 is 1400. And x times 24 is 24x. Divide both sides by 24, we get just x. 1400 divided by 24 is 58 point repeating 3. So that means that a 14 karat gold ring is approximately 58% gold. Here it says use the information above to find the number of carats in a bracelet that is 42% gold. Round your answer to the nearest whole number. So let's go ahead and use the proportion method on that. Why not? So we're looking for what if it were 42% gold? So 42 parts of 100. And we know again that the whole can be no greater than 24. So that's going to be 24. If it's pure gold, it would be 24. And the part is the unknown. So 100 times x is 100x. And 42 times 24, do I want to try that? 428, 40 plus another. No, I don't want to do that. 42 by 24 equals 1008. 1008. 42 by 24. 42 by 20. Yep, look at my calculator, make sure I got that right. And then I'm going to go ahead and divide both sides by 100. And if I divide by 100, that should move over 2 places, right, for 10.08. And divide that by 100. And indeed it is 10.08. It's one of those days, just want to check my mental math there. So, and that means that it would be roughly a 10.08. So that means that x is approximately 10, right? So that would be pretty much, it would be about a 10 karat piece of jewelry. Is it a ring? Oh, bracelet. So it'd be a 10 karat bracelet. So here we are at our guided practice. Let's see. 75% of 40. Well, 75% is 3/4, right? And 40, if we split it into 4 equal parts, so it'd be 10 parts each. 10 times 4 is 40. And 3 of those, 3/4, would be 30. So that's going to be 30%. That's just simply from understanding the common percentages that we saw in that chart, okay? Something else that might be a little more difficult is this 12.5 of 168. That one might be a little bit trickier, right? I don't have 12.5% memorized, and 168 is not a nice simple number like over here with 40. So let's go ahead and think of 12.5% as 12.5%. So I want to go from percent to a decimal. So I'm going to move the decimal to the left. So 2 places, that's going to be 0.125 as a decimal. So this right here, I've changed over to 0.125. Of means to multiply. And we're going to do 168, multiplying there, times the 168. And it says to find whatever this is. That means that that's going to give us our answer here. So if I put in 0.125 and I multiply that times 168, I'm going to get an answer of 21. 21. So let's erase this so we can see a little better. So 12.5% of 168 is 21. Let's see. Let's go ahead and use a proportion on our next example. What percent of 40 is 25? So what percent of 40 is 25? So they say what percent? So the percent's the unknown, right? So we're going to go x over 100. And the part goes up top. What percent of 40 is 25? Well, 40 is the whole, so 25 is the part. So 25 times 100 is 2500. And 40 times x is 40x. Now let's divide both sides by 40. And nope, I don't want to do that either. 2500 and divide that by 40. So 60, that's why I didn't want to do it. It is a decimal. The answer is 62.5. So this one here, 62.5. All right, we're at 29 minutes on this video, so let's go ahead. What is 1% of 8? Well, I know that, here, I could do this one mentally, I think. Check this out. 10% of 8 is 0.8. I just moved the decimal over one place, right? 0.8, 10%. 1 is 10% of 10. So if I move it over one more, is it going to be 0.08? Let's go ahead and double check our work with the calculator. So let's do this another way. 1% is what percent of 1 is what percent of 8. So 1's the part, 8 is the whole. The percent's what we're missing over 100. 1 times 100 is 100. And 8 times x is 8x. Divide both sides by 8. Let's see if I was correct. 100 divided by 8 equals, nope, something's not right. 1 is what percent of 8? Well, I was looking for percentage, right? Well, I was trying a percent. I thought that was a percent. I'm just totally off over here. Why didn't someone tell me that? You're yelling at your screen. What are you doing? What are you doing? I took 1% of 8. That's what I did. I calculated 1% of 8, and that is not what this question is asking. It wants to know 1 is what percent, so we're actually looking for a percentage, and that percentage comes out to be 12.5, and that is a percent, so it would be 12.5% because we don't have to move the decimal because we used the proportion percentage proportion. There we go. And now let's go ahead and try some of the percentage equation stuff. So 28% is, so this would be 28 is means equal. 32% as a decimal, move the decimal over two places, percent to decimal, move it over two places, 0.32. Of means to multiply, what number x? So we would have 28 equals 0.32x. Divides both sides by 0.32. 0.32. And that would leave us just x on the right. And 28 divided by 0.32 equals 87.5. 87.5. So 28 is 32% of what number? Yep, 87 is the whole. 87.5. So that's the whole we're looking for there. And let's pick 13 because I see it's 105%. So let's try a percentage greater than 105. So 105% as a decimal, move it over two places, is 1.05. Of means to multiply. What number is the unknown? So that's x. Is means equals. And 37.8 is our number there. So we end up with 1.05x equals 37.8. Let's divide both sides by 1.05 so we can isolate that variable x. And what we do to one side, we're going to do to the other. And whenever we do 37.8, divide that by 1.05, and we get 36. So 36. And that's the part we're missing, right? 105% of what number is 37, right? Percent of the part. Yeah. So 36 was the whole, and 37 is the part. And 37 is greater, a little bit more than 36, and 105% is a little bit more than 100%. So that answer indeed makes sense. All right, so that is my entire presentation for Algebra 1, Chapter 2, Lesson 9, Percents. Thank you.